Hey guys, so in this video we will be going over the Python interview problem where we have to merge two sorted linked lists. So in order to do this, in order to understand kind of what's going on, let's take two linked lists, L1, which has two nodes, one whose first block is pointing to the value 4, and this points to the node whose first block points to the value 7. Then we have L2, which has the head node have its first block point to 3, followed by 6, followed by 9, and followed by 12. So our goal is to create a function definition like this, such that after we run it, we can get a merged linked list that puts all of these nodes from L1 and L2 into one linked list in ascending order based on the value. So for example, after running this, we should be able to return a linked list whose head node points to 3, followed by a node whose first block points to 4, followed by a node, whose first block points to 6, then 7, then 9, and finally 12. And we should be able to return this linked list. So in order to actually implement this function definition, we first need to be able to define a node. So a node in this case would be this, right? Or this, or any of these nodes that you see, where the first block is going to point to a value and the second block is going to point to the next node. So here is a class node definition that I usually use to initialize my nodes, where we have class node and self.value is equal to value, so the first block of the node, and then self.nextNode will be initialized to none. None basically means that this doesn't point to anything right now, but using our Python code, we will eventually be able to link it to other nodes, and we will be showing that later. So now that we initialize the class node, we have to actually create the merge definition. Okay, so now that we have this function definition header, we want to be able to combine L1 and L2 so that we can return a linked list like so, where 3, the node that contains 3 is first, followed by which node has the value that comes after 3. It would be the node in L1, so that would come after, and we would do that same thing for 6, 7, 9, and 12. So in order to begin, we have to create a variable called dummy head, and dummy head is a variable that we use in order to remove any edge cases dealing with head node versus the body node, because as you might recall, a head node does not have an arrow pointing to it, whereas a body node does. So this would be a body node, this would be a head node. So in order to avoid having an additional if statement dealing with a head node, we can create a dummy node like so. Dummy node, I'm going to call it dummy head, where it makes the head node a body node because there's now a arrow that points to it. So it's just a way to simplify our code and make it a lot easier to deal with every single situation possible. So head node, or dummy head, is going to be equal to an iterator variable called cur, and I'll show you later on how we use cur, but just know that cur is another variable, and node is going to be using the class node definition, so that cur will have the dot value and dot next node attributes, and so will dummy head. So both of these attributes now have dot value and dot next node. But more importantly, we've now been able to create a place where we can now take the nodes from L1 and L2 and put them into this new merged linked list, starting with dummy head, which is this node. This node will always be dummy head, and cur, which will change depending on the newest node in the linked list. So say we have 3 here, which will eventually happen because we're trying to find the node with the smallest value. Once we add that node to this merged linked list, the cur variable will iterate so that cur is now equal to this node rather than this node. And I've displayed that right here. So this is the beginning of our merged linked list, where we have dummy head, which will always be this node, the first node, and cur, which will change depending on what the new tail of the linked list is. Okay, so now that we have our first line of our merged function definition, we should now be able to sort of visualize what's going on before we proceed with the code. So L1 and L2 are going to be on the beginning of the linked lists, the respective linked lists, where L1 is going to be pointing to the first node of L1, and L2 is going to be pointing to the first node of L2. So we need to be able to do a bunch of different things. Firstly, we have to be able to move L2 and L1 every time we pluck a node from either one of the lists into our merged linked list, which is currently empty with only the dummy head. And after we add a node like so, we should be able to change the value of the respective linked list. So in this case, it was coming from L2, where L2 is no longer pointing to 3, and we can move on to the next node. Secondly, we need to be able to find a way to iterate this cur variable so that cur will always be pointing to the tail of the merged linked list. And remember that this is the linked list that we're supposed to be returning after all the code from this merged function is done executing. So this function, this return value, will always be returning a new node every time the definition is run. So we have to be able to do those things. So in order to do that, I created a visual picture of what's going on, and it's important to look at this visually, because when you're implementing this code by yourself, you want to be able to do it from having a good picture of what's going on, rather than memorizing the code and not really understanding what's going on behind it. And that's something that I highly emphasize. So before we go into this picture and we kind of figure out what's going on here, we still have to find a way to identify which node out of L1 and L2 is going after dummy head. And by visually looking at it, it seems pretty obvious. It's going to be L2. So how do we represent that when we're iterating through the linked list and figuring out which one goes next? That's done by saying if L2 dot value is less than L1 dot value, then you should move that node, so in this case it would be this node, right after this dummy head. Okay, that sounds cool, but what happens when we reach a point where L2 reaches a null. In other words, what if it reaches, for example, what if L1 reaches the node after the node that has the value 7? Well, there's no node here, so how would we account for this? Also, what if L2 reached the node after 12? What would we do there? So in order to account for this edge case, we would have to create a loop of some sort that would end after L2 or L1 reached a null node. And that would be, in this case, one possible way to do it is saying while L1 and L2. And this is basically saying, and let me move this. Indentation is super important, by the way, so make sure that you have a tab space after when you're indenting. But while L1 and L2 basically means that while L1 is pointing to a node that exists, so in this case 4, this node exists because it has the value 4, and this node exists because it has the value 7. But when L1 reaches here, then this linked list is going to end because L1 is no longer true. Now that we have this if statement and this while loop, we can now look at what's actually going on in the meat of the problem, where we're actually iterating through L1 and L2 and adding the node from each of these, and we're kind of plucking it like an apple from a tree. We're plucking that apple and we're putting it into this return statement. That's just a collection of nodes that we get from L1 and L2. So here we have to, within this if statement, we have to write 3 things, and I'll explain them with the picture, but I just want to write them right now. In that cur.next node will equal L1, and L2, because we're comparing L2 is less than L1. Cur.next node will equal L2, and L2 will equal L2.next node. Now this is basically iterating the cur iterator and moving it to the next node that follows, and we're also incrementing the L2 arrow to point to the next node. So visually this will look like, first L2 is equal to cur.next node, so we're adding the node that L2 is currently on, which is this node, and we're adding it to the tail of our merged linked list. And in this case, the merged linked list is cur.next node, right? Because the second block of the node that cur is currently on is pointing to the next node. So with this statement, we are effectively adding the node from L2, which is this, to our merged linked list. So now we have our first addition to our merged linked list. Now the second step is to move whichever node we've already moved into the merged linked list and make sure that L2 is, because we're done with it. We're done using this node, so we can move L2 to the next node so that it can add the next node whenever the time comes. So what we're doing now is we're going to move the L2 arrow to point to the node that contains 6. And that will be displayed right, I think I wrote it right here, yeah. So this purple arrow represents L2 and L1. L1 isn't even actually here. L1 is still here because we haven't moved L1 yet. But L2 is moved, and we've done that through this statement where L2 equals L2.next node. Now the next step, once we're done with both of those, is we need a way to increment this cur variable, because this cur variable is still at the dummy head, and we have to move it to the tail because the next time we add a node to this, we need to make it so that cur will just be able to move again. So in order to do this, we have to move cur to this area, and that's done by a very simple method. It's just cur equals cur dot next node, where next node is the node that this arrow, this pointer from the first node is pointing to. So this will effectively move cur from here to here, and I've shown that here where dummy head is no longer cur, and cur is now on 3. So we've done these 3 steps. First, we've set L2 to be the value of the next node in our merged linked list, and then we've incremented the L2 so that it's pointing to the next node, and then we're incrementing the cur variable to point to the next node in the merged linked list as well. So these 3 steps will be repeated for the majority of the code, and that's pretty much all of what you need to do, but we have to account for the other case, right? So we said that if L2.value is less than L1.value, we do this. But what if we have it where L1.value is less than L2.value? So in this picture, we see that L1 is actually less than L2. L1.value is less than L2.value. So we have to have some stuff to do in this situation. So in order to identify that 4 is smaller than 6, we do the exact same thing that we did for the if statement, except do it for L1 instead of L2. So we do else, and we do cur.nextNode equals L1, and L1 equals L1.nextNode. Now this does the exact same thing, right? Because now that cur is no longer here, is actually on the node that has a value 3, we can now make cur.nextNode, which is going to be here, to have whatever node L1 is on. And L1 is on 4, the node that contains 4. So we have 4 right here, and that's what L1 equals L1.nextNode does. Cur.nextNode equals L1 does. Now we have to do L1 equals L1.nextNode because we have to increment L1 since we're done messing with the node that has 4. And that's what we do here when we move it. And that's all you have to do if L1.value is less than L2.value. And then finally, since cur equals cur.nextNode is done in both the if statement and the else statement, we can put it outside like so. Cur equals cur.nextNode. Since even if we go through if and even if we go through else, we're still going to do this step. So we don't need to put it in both if and else statements. So now that we did cur equals cur.nextNode, we should move this cur statement to the next node. So we're going to have it so that cur is now here. And we keep doing this with L1 and L2 until we reach the end of either list. And when we reach the end of either list, this while statement will no longer hold true because one of these lists is no longer true. So let's keep doing it. So now we're at the point where our merged linked list has 4 as the tail node, and we have L1 pointing to the tail of L1 and L2 pointing to a body node, which is 6. So eventually L1 is going to end up being false because L1 is going to point here. But let's keep working on adding on to the merged linked list and deal with this situation when it comes. So we go back, we check so first of all we finished cur equals cur.nextNode, and we finished this else statement. So now we go back to while L1 and L2, and we see is it as L1 and L2 true? we go back to here and we see yes, L1 is still pointing to a node, L2 is still pointing to a node. So we can keep going with the while loop. If L2.value is less than L1.value, does this hold true? Well, L1 is on the node that contains 7, and L2 is on the node that contains 6. Since L2 is less than L1, L2.value is less than L1.value, we can go on with this statement. And it says cur.nextNode equals L2. So cur.nextNode equals L2. So L2 is currently on 6. So we're going to put 6 here. And then we're going to increment L2. And let me move this to the side. We're going to increment L2 so that L2 is now pointing to 9. Then we do cur equals cur.nextNode, where this cur variable is moved to next node. Whoops. Let me just do it the old school way. Cur, erase it. Alright, so then we're done with that. And now we have to go back, since we're done with this, let me erase this. Let's go back to the while statement. While L1 and L2 are true. So L1 and L2 are both true since L1 is pointing to 7 and L2 is pointing to 9. So we see which one is less than each other, and L1.value, which is 7, is less than L2.value, which is 9. So we go to this else statement, and we make cur.nextNode equal to L1. So cur.nextNode, which is this node, is equal to L1, and L1 is currently pointing to 7. And then we move the L1, this statement, to point to the next node. And L1 is now going to point to basically nothing because there's no node here, but we still make sure to point it there. And remember when we said this while L1 and L2 will no longer hold true when one of the nodes is pointing to nothing? Well, we'll deal with that after we're done executing, because we're still on the step where we are iterating all the variables. And once we finish doing that, we can deal with while. So now that we have L1 pointing to the next node, we can finally move cur.nextNode, cur, we can move that to cur.nextNode, which is the node that has 7. Now we can go back to the while loop, and we see that while L1 and L2 is not true anymore because L1 is null. So because of that, we have to find a way to account for 9 and 12, since in our merged linked list, we still need 9 and 12. But we can't go into this while loop anymore since L1 is no longer true. So because of that, we need to have a statement outside of this while loop, so in the same indentation area as the while loop, that deals with this edge case. So 9 and 12 have to be accounted for. Let me erase all of this. L1 is pointing here, L2 is pointing here. We don't need this anymore. Okay, so in order to account for this, one way we can do it is cur.nextNode equals L1 or L2. So we're basically saying that cur.nextNode, which is going to be whatever node is going to be here, is going to be the node that is still true. So between L1 and L2, L2 is still true because it's pointing to a node that has a value. So because of that, L1 or L2 L2 will be true, and cur.next node will equal that node, whatever node is that L2 is pointing to. So in this case, L2 is pointing to 9, so we put a 9, the node that contains the value 9 here, and we keep doing this because L2 is going to be 9 and 12, right? So in this case, we're going to also add 12. Whoops, there we go. And we've basically finished merging the linked list. So we have this full merged linked list as the picture we've shown above. This is the linked list we're supposed to return, and we've pretty much done that. And finally, we have to, in our code, return the actual linked list here. So in order to do that, we do return, and we look at this dummy head dot next node. And this is basically saying that every node that's been iterated will be accounted for with this next node. So my recommendation after completing this tutorial is to try it out yourself and see if you can get the same answer. Thank you for watching, and hope to see you in the next video.